and we know the impact of unplanned shutdowns on miners. It's absolutely chaos, and it's a huge cost. The comminution segment is equivalent to 1% of what the world consumes in energy. That's a massive number when you think about it, right?
Yeah.
How do we help the industry reduce energy around the comminution circuits?
Yeah. Well, welcome to Mining Now. And we're live from the trade show floor at the annual Prospector and Developers Association Convention, PDAC, and it's from Toronto, Canada. My name's Roy Slack, and I'm your host today, and it's my pleasure to be speaking with Phil Blondin, who's the Director of Capital Sales for North America for Weir. Phil, thanks for joining us.
Thank you, Roy. Great to be with you.
And PDAC's always exciting, a big show. I always like to start off by getting a little bit about your personal background.
Yeah.
So where did you get started in the industry, and how did you come to be with Weir?
Yeah, so mechanical engineer by trade. I graduated from ETS in Montreal in 2004. So surprisingly enough, Weir was my first opportunity as a young junior engineer. And here I am 21 years later, still working for Weir, still in the mining industry. So it's been a fun and exciting and really rewarding journey, both working for Weir and in the mining industry.
So you're going to have to bear with me because I'm a mining engineer.
Okay.
So my questions will be pretty basic, but you know your stuff and
Right.
You've been with the group, so you'll have no problem with that. But for people who aren't familiar with Weir, and we talked about this earlier,
Right.
Back in the day, when I thought Weir, I thought pumps.
Right.
And I've looked at the website. I do a little research before the show. Weir is so much more than that. Tell us about Weir.
Yeah, that's it, and that's a reaction that we get sometimes. You know, we're known for our pumps, we're known for our cyclones, but obviously Weir is a lot more than that.
Yeah.
And we have sustainability on our mind anytime we develop technology and anytime we look at customer problems. And I think when you look at Weir and you look at our strength and what we're really known for, we're a global company. So we have service centers, we have individuals, key individuals that are technically knowledgeable, that are placed close to where our customers are, and our aftermarket support and our reputation when it comes to supporting our equipment in the field is top-notch. It's industry-leading. And when you look at like what we're developing and innovation, everything is sustainably based. So we're working on moving less rocks, we're working on consuming less energy with our equipment. We're looking on reducing the amount of water that we use, and then, of course, reducing ultimately the tailings that we're sending to waste deposits.
Yeah, I'm glad you mentioned that because as an operator, first thing we want to do is get good equipment. But we often decide on our suppliers based on their support after and their technical knowledge, so they can adapt to our challenges, because all your clients have different challenges.
Yeah, that's right. And we try to have not a one solution fits all. We try to sit down with our customers and understand what their needs are. And the reality is, because we're a global company, we operate in all of the continents. Yeah. And each continent has their different challenges. It's not the same in Canada as it is in Australia. Obviously, the water,
we're going to talk about water,
right? The first thing, right? And in Canada, it's like there's lakes everywhere. And then I speak to my Aussie colleagues, and they're like, "Wow, water is really an issue."
Yeah.
So as an organization, we really need to adapt to all of those problems.
Yeah. I remember driving out to Kalgoorlie and the big pipes by the road.
Right.
What are they for? Water.
That's right. Yeah.
And you come from Canada and you say, "Oh, what's the problem?" Anyway,
well, that's right. Well, I was just talking to a customer of ours that's in Latin America, and they're working on desalinization plants close to the ocean. And we look at this from a Canadian, even a North American perspective. You're like, wow, those are challenges that we're not used to seeing here, but they exist.
Yeah. So I've already gone off script, so I got to
that's okay.
I got to come back on.
Go back.
Lots of interesting things to talk about, but your website and some of your promo, I always look at this. Moving less rock.
Yes.
Using less energy.
Yes.
Using water wisely and creating less waste.
Right.
These are all things that we aspire to in our industry. And I think at the same time, we're talking about win-wins here, because at the same time, we're getting more ounces or pounds or tons or whatever you're mining. So tell us a bit about how Weir is doing this, because you're keying in on some key sustainability challenges in our industry.
Yeah, I mean, let's start from the beginning, right? Weir is a cradle to grave organization. It means we're in the mine pit, we're in the comminution, we're in the process plant, and we're in tailor. So we have solutions to cover these four things.
Yeah.
But if you start with the first one, which is moving less rocks, we have Motion Metrics, which has great technology. They're helping our customers kind of understand mine planning better and just getting them to maximize the output and make sure that
Okay.
their operations are efficient. So they have equipment that are able to recognize if shovel buckets have boulders in them. They're able to detect the particle size distributions that of rocks on the rock trucks. So as the product is coming into the comminution section of the plant, they're able to kind of lively get information and tell the operators if there's any issue with the product that's coming in, and they're able to do this in real time and react. And that's our way of making our customers more efficient in their operation.
Yeah. So I'm going to jump around here because you've segued into something that I was really interested in, because traditionally companies were talking about equipment, but you're starting to talk about data now.
Yeah.
It's not just about equipment anymore. It's about collecting the data that the equipment experiences and using it to help your customers.
Yeah, that's right. And we'll talk about energy next, but I'd like to dive into that digital and that data, right? And Weir has a brand called Next, and that brand is technology that is under our digital umbrella, and it helps our customers making sure that they have reading on how their equipment is performing, and they're mixing condition monitoring to performance data. And then if you put AI as an umbrella on top of all of this, we're really able to maximize the full potential that our equipment have in our client's operation.
Yeah. Like the way I see it, because I'm not that adept in this area, not that adept in a lot of areas, but especially AI. But we end up getting so much data, but it sounds like what you guys are able to do is to find the data that makes the difference.
Yeah, and I mean, let's use some real life examples,
Yeah,
right?
sure.
So if you have, for example, a slurry pump that's running at a mine site, and then you have condition monitoring, so you have like RTDs, you have your vibration, your temperature sensors,
Yeah.
and then you have, let's say, a performance package, which would have wear monitoring on your pumps.
Okay.
Then like you'd be operating your pumps, and you know that pump is supposed to go down every 2,000 and 4,000 hours, right? But let's say there's been something unusual that's happened during the process. Maybe the rock is harder, or you're experiencing like a higher particle size distribution, or you even have like boulders or grinding media,
or batching instead of continuous.
correct, right? So let's say you have grinding media
different.
that goes into your sump, and all of a sudden the pump will see premature wear.
Yeah.
So how do you know that, right? How can the operator have access to the fact that the pump is not going to make the outage like they normally does?
Yeah.
So with performance monitoring, you're able to have live information on how much material you have left on your wear liner in your pump.
Yeah.
And then if you need to bring a shutdown forward, then you're able to do so with accurate, right, intelligent information. Correct. You can plan it. And if you don't, I mean, we know the impact of unplanned shutdowns on miners. It's absolutely chaos, and it's a huge cost.
Yeah.
So that's how we're using digital information data to make our customer more efficient ultimately.
Yeah. We talked about using less energy,
Right.
which is a big deal in our industry, a big deal everywhere.
Right.
And so how does this come into the equation?
Yeah, and I think when Weir looked at its entire flow sheet, and we wanted to make a difference, we're like, which segment do we attack first?
Yeah.
And I think the obvious one is comminution. If you look at comminution in general, I mean, the entire mining industry, the comminution segment is equivalent to 1% of what the world consumes in energy.
That's just, I mean, that's
a massive number when you think about it, right?
Yeah.
So as an organization, if we go like 1 + 1, you go like, okay, we need to, like, our R&D needs to be focused on how do we help the industry reduce energy around the comminution circuits.
Yeah. And so this is for me, like comminution for me is drill and blast. So I'm not a processing guy. But like you say, this has become a focal point in our industry for a couple of reasons. For the energy consumption, we're concerned about tailings. Less waste means less tailings. There's all kinds of things that play into this. And so want to talk about high pressure grinding rolls.
Right.
Okay. And we talked before about acronyms.
Yeah.
So I said that word. So now you can call it, what do you call it?
Yeah. Thank you.
HPGRs?
Yeah, I say HPGR, but I
Okay.
think you're right. We got to say it once, like high pressure grinding rolls, and that's been our number one focus in terms of how we can help the comminution circuit reduce energy.
Yeah.
And there's significant advantages of using a high pressure grinding roll from an energy perspective compared to what a lot of the traditional circuits have been using with semi-autogenous grinding mills, so SAGs. And so Weir's done a lot of research around HPGR, stir mill, coarse particle flotation, and how we can bring those three equipments together to develop flow sheet of the future in order to have some significant gains on the energy side.
Yeah, because it's not just that piece of equipment. It's a combination of innovative approaches that makes the large difference.
Well, correct, and it depends on. There's always trade-offs, right?
Yeah.
Like we work with some clients where some of our circuits are HPGRs followed by a ball mill, and we work with other customers that have been HPGR vertical stir mill coarse particle flotations.
Yeah.
And we have some examples of success that we've implemented in the industry that we could talk about later.
Yeah. All of these things we've talked about so far all tie into sustainability.
Yeah, that's right, and of course, like we were chatting about comminution and things that we can help there, and it helps energy when you're combining an HPGR to replace a SAG, and when you're looking at a vertical stir mill to replace a ball mill, and you're able to grind coarser using a coarse particle flotation. Basically, that's a lot of energy that would have gone into reducing particles to a finer size, getting them ready for flotation, but now using the technology of CPF, coarse particle flotation, and that's worked in conjunction with our partner Erie's, then you're able to grind coarser and then float. Yeah. And then, of course, grinding coarser.
Less energy, for sure.
It's obvious, right? It's less energy. But also the other element that we looked at from a grinding perspective is HPGRs are run dry. So where traditionally you would have a SAG mill where you need to create a slurry within the body of the SAG, then HPGR can run dry, and then you don't have that use of water. You can kind of save that precious element to later in your flow sheet.
Yeah.
And we have some examples of that.
And I do want to emphasize what you said earlier, because we are here in Canada. We're right beside one of the Great Lakes. Mm-hmm. Water doesn't seem to be as big an issue for us, but I don't know if I'd say most parts of the world. Maybe it is most parts of the world where water is one of the key issues. I know I'm on the board of Torex. We operate in central Mexico. The work in Chile. You mentioned Australia.
Yeah.
Lots of places in the world where water is a very precious commodity.
Yeah, that's right. And it's like we talked about before. I'm Canadian born, so of course my heritage has been mostly around Canadian mines, and you're right, those are not the number one sort of issues or priority that our customer have in this side of the North American border, but in the U.S., you look at like the Nevada and the Arizona section, which a lot of new projects are being developed. I constantly have conversation with customer about how do we manage water? How do we make sure that every ounce and every gallon of water that we use within our circuit is maximized optimally in order not to waste anything? Because the thing is, a lot of permits are tied to how are you going able to use that water wisely. Yeah. And what we know permitting cycles can be long, and I think in some cases it's rightfully so, because we want to make sure that as an industry we leave a good impression on the future the future society that's surrounding those mines, and and how water is being managed is a key element to that.
Yeah, and what you mentioned there when you talked about permitting, there was a bit of an epiphany for me because permitting can often limit the tons per day that you mine, right? There's so much water required to process based on the permits you have for water take or water disposal.
Yeah.
This is how much you can mine. If you need less water, you may actually be able to increase your tons per day operating.
Well, that's correct, right? So as you said, that's exactly right. So permitting will say, okay, you can bring a certain amount of water from fresh feed, whether it's lakes, adjacent lakes, or river streams, and so on. But then you're within that confine of your perimeter, and you have a certain amount of water to work with. And so anytime you can introduce an equipment that uses less water. And, we talked about HPGRs and, compared to SAGs, but it's the same thing for our slurry pumps, for example.
Yes.
We have technology with like low flow gland water that allows you to run your pump, but with less water. And those are all kinds of things that we was looking at from a technology perspective that can help our clients like get their permits and operate sustainably.
And I'll go back to energy for just a second because energy is expensive usually. And can increase your carbon footprint. If you're on a remote operation where you're diesel generating power, it's very expensive, and it's a big impact to your carbon footprint. So all of these things, we're getting back to the sustainable.
Yeah,
but
I think
it's a win-win, right?
Yeah,
sustainable and cost.
Correct, and I think like I mentioned at the beginning, right, when we looked at the entire flow sheet. Comminution was an easy target for us from an energy perspective, and like Weir's work with some third party consulting firms to look at flow sheets, look at and compare that to traditional flow sheet and see how much energy we could really save. And when you're looking at combining technologies such as HPGR, vertical stir mills, and coarse particle flotation, numbers around 40% energy savings came out. And that's significant. Like it cannot be neglected, and I think as we continue to work in an industry where there's still some resistance around these new technologies. I mean, HPGR is not in every flow sheet, and we will continue that journey until we convince people that that's the way to go.
So I've got a new mine.
Yeah.
So we can design from scratch, and you can implement all these. What about an existing operation? Like, are there certain elements to the flow sheet that make sense to take a second look at?
Yeah, I mean, there's multiple ways that you can go in an existing flow sheet. I mean, we've worked with customers that want to increase capacity.
Okay, sure.
So they're looking at, okay, how do I increase capacity without doing a copy paste and building a second concentrator right beside? And we've worked with customers that said, okay, so my SAG mill is being fed with particle size of X dimension, but you could put an HPGR ahead of your SAG mill.
Got it.
So you're basically your HPGR is acting as a tertiary crusher.
Yeah.
And it's taking the load off of your SAG mill.
Yeah.
And your ball mill. So by doing that, by feeding your SAG mill with smaller particle size, so smaller product, you're able to increase the tonnage that mine's able to handle.
So you put something in instead of a parallel circuit, you put something in series and boost your.
Correct. Yeah. And of course, you need to kind of go down the line and see where your bottleneck's going to be, and can flotation, can your pumping system, can they handle that extra load? But those are some of the studies that we do with our customers to see if they can maximize their operation that way.
We see this in industry. I've got this feeling about mining. We're innovative, but adoption is our challenge. And so you guys are a very innovative company. So now we're going to talk about the adoption challenge. Is how do you get from a couple of customers that use it to a mainstream acceptance of a new technology? So
yeah, that's a great question, and I think the industry knows that the easy ore is gone. It's becoming harder and harder to get to your deposits, and the ore is getting harder as well.
Yeah.
So I think everything is lining up towards the industry being ready for a shift of mindset
Yeah.
towards high pressure grinding roll technology. But yet, you're right. I still see a lot of flow sheets being developed, and they stick with traditional SAG and ball mill circuits.
Yeah.
So I think it's important first and foremost. An HPGR is not a one size fits all, and it's
Yeah.
not going to fit in every application. And you have advantages. The harder your ore is, the more energy saving gap
Sure.
that you're going to have between
Sure.
a traditional sand mill. So there's still going to be some instances where SAG is the way to go. But I think as an industry, what we need to challenge is when it's that in that sweet spot where you go, okay, A times B is pretty low. This should be an HPGR circuit, and then we see a SAG and ball. And I think that has to do with multiple things. I think the industry in general is a pretty conservative industry. I think you've
There's
been around.
the industry takes lots of risks on lots of things, but when
Correct.
it comes to engineering, that's where they try to be very conservative.
Correct. So I think nobody wants to be first, and that goes for HPGR, but that goes for other products as well. But there are more and more HPGRs that are being installed in hard rock mining these days. If you look at the technology of HPGR, it's been around for 25 years. So it's not like if something that we developed yesterday, and the industry is kind of cold to try it.
Yeah.
So I think like some concerns around cold climate, or some of the resistance that I'd heard from customers that I sat down with. But then you have Côté Gold and Greenstone, which are two mines in Ontario that have been operating for a year with HPGR and have had great success. So I think it's going to take time. I think it requires people like me and people like you to continue to spread the message that it's a technology that does not increase their risk in terms of operation.
Yeah.
I think that there's also the reality that the industry is very capex sensitive.
Yeah.
Sometimes customers look at the overall, and they look at the price of an HPGR and the surrounding ancillaries that go around with that, and they do the trade off with SAG, and then sometimes the HPGR circuit can be slightly more expensive, and then your gain happens over
It's always capital versus operating.
Capital versus operating, and what's your return on investment. So that's the I guess the sweet spot that we have to find with customers that we meet.
But those are all numbers that can be generated. It seems to me, if you're designing a new flow sheet, you take a look at it, right? Just to see if it works, what the savings would be. It just seems like something natural. It's an option that's out there. So take a first look at it, see if it makes sense.
Yeah, correct. And there's a lot of labs that specialize in doing trade-off, and Weir is no different. We have our own laboratories. We're able to take samples from customers. We're able to do HPGR testing.
Okay.
We test different pressures. We test different speeds, and then we see the results. And then we're able to also do a comparison with how your circuit would look like with traditional SABC.
Yeah.
And we do both the comparison from a CapEx perspective and from an OpEx perspective. And we're able to offer our opinion on what your return on investment would be. And then, of course, at the end, we're there as a partner and as a consultant when it comes to flow sheet designing, and the final decision becomes the customer's decision.
Are we at Terraflow?
Let's do Terraflow.
Okay, I like Terraflow. Let's go with the flow.
Yeah. Perfect. Okay, so Terraflowing, so it's a proprietary design that Weir's created to basically dewater tailings. Had you heard of Terraflowing before? First time?
You know what? Again, I'm on the board of Torex, and we are doing dry stacking in Mexico.
Yeah.
I'm familiar with the process in general. I'm not familiar with this product name.
I see. So Terraflowing it's a brand name. So it's not one product in particular.
Okay.
It's a combination of multiple products.
Okay.
So our Weir process engineers would sit down with the customer and kind of understand what their challenges are.
Yeah,
right?
Sure.
Are they looking at reducing the footprint as much as possible on their tailings disposal? Are they looking to create a byproduct with tailings? So do they need to use it in a paste backfill application, or do they want to mix it with some waste rock to create products? So we're working with our customers to try to create value out of tailings. So if you look at like Terraflowing from a fundamental perspective, like I mentioned, it's not one product in particular. It's a combination of product.
Okay.
It can be cyclones. It can be thickeners. You can have centrifuges. You can have decanters, and you're able to generate fraction products from all of these technologies. Now you can use them on their own, or you can combine them to produce a paste. So when we talked about before, how do we balance efficiency versus sustainability? And
Yeah.
I think sometimes people, have when you look at tailings, they have the thought of, okay, if I want to save water, I need to go to filter and filter presses.
Yeah.
And then you end up with, and you end up with cake. You end up with dry stacking
Yeah.
as a technology. And there's a concept, or people sometimes feel that dry stacking is the most water efficient way of managing tailings. It may be the most water efficient way, but is it the most sustainable way when you look at the big picture?
Yeah.
Because then what do you do with your dry stacking? Then you need to convey it somewhere. You need to use trucks to
Need a
move it.
lot of room.
Correct.
For sure.
You need to use trucks to move it from point A to point B. And then, those trucks are run on diesel. So we feel that there's an opportunity in paste. And that's where Weir is focusing its energy. And Terraflowing is our technology that we use in order to convey that message, and to look at trade-off studies, to design flow sheet, to produce the right paste for our customers. And the beauty of paste is that it's pumpable.
Yeah.
So that's a big difference between using dry stacking, which can be energy demanding.
Yeah. So I've got a tailings dam, and my tailings is I won't say liquid, but you need a dam.
Yeah.
Right. And then you go dry stacking. That's the other end of the spectrum.
Yeah.
Where you've squeezed as much of the water out as you can. There's still some water in it.
Yeah.
But you've squeezed it out. But now you've got something that is pumpable.
That's right.
So this is my mining engineer thinking, but now you've created something that's pumpable, so you can move it without trucks. You can move it. Maybe you use conveyors as a spreader or whatever, but most of the movement is through pipeline.
That's right. And we're able to get to a level that's close to 77% in terms of solid concentration that the pump can handle and move through long distances.
Which is very close to dry stacking.
Which is very close.
Not far. Yeah.
Exactly.
In terms of water content.
Correct. And then we're able to do it in an energy efficient way.
Yeah.
So that's something that we're developing with our customers, that we'll continue to develop, because we really feel that there's a niche for our customers and the sustainability around their tailings management.
So Terraflowing is a concept.
Correct.
And how you get there depends on the customer, depends on their processing.
Exactly.
But you have the tools to pull it all together.
Correct.
It sounds like each one will be a hybrid in a way, because each one may use different pieces of equipment to get there.
Well, that's right, because no mine is equal.
Yeah.
Right. And the type of ore that we support our customers with is different.
Yeah.
So the way a copper mine would react would be different than an iron ore mine or a coal mine.
For sure. And just in terms of tonnage, you look at a gold mine versus a copper mine, and the difference in production per day. And so, there's lots of different things you have to consider.
So Weir's Technology Centers has done testing on multiple ore types through the Terraflowing umbrella.
Okay.
And we've used, like I mentioned before, technologies of cyclones, and then thickening, and then centrifuges. And then we study those byproducts. And we're able to then produce reports for our customers and say, hey, this is what you're going to be looking at. We feel that this is the best flow sheet that will suit your needs. Yeah. And that's what Terraflowing is all about.
Yeah, good. I think we've talked about this before, but it's worth touching on again, because one of the challenges in our industry is obviously tailings.
Mm-hmm.
And we're all looking at how we reduce waste.
Yep.
And some people look at different methods on the front end and on the mining end. But some of the things you've already talked about are waste reduction on its own. But let's talk about waste.
Yeah. And obviously, we are as an organization, we work with our customers to try to reduce waste as much as possible.
Yeah.
And then we talked about like there's various ways that you can do this. You can use centrifugal pumps and send waste at 45-50% solids. You have that pace we kind of touched on, and then you can have dry stacking. And when we work with our customers, we try to look at waste as how can we use tailings and make it a product of value for them. And then we have some examples of that. We use paste for backfilling.
Okay.
So we've worked with Newmont Brucejack in northern British Columbia, and when you use tailings and you combine that with cement and you use again positive displacement pump, and they are pumping that underground, and that paste backfill, is filling those already mined areas and allows them to create stability around those sections so that they can mine additional sections. So again, using waste as a value add, and it becomes a product.
We've already well, you mentioned Brucejack.
Yep.
Project I'm very familiar with.
Yep.
Any other examples that you want to tell our audience about?
Yeah, I think so we talked about let's go back to comminution for a little while. We Iron Bridge is the biggest mining project, and that's a Fortescue property.
Yeah.
That was designed and built without a tumbling mill.
Okay.
So that's a mine site in Western Australia that combines the technology of HPGRs, of vertical stir mills, and air classification.
Yeah, so that's in Australia, and of course we talked about the challenges they have with water or lack thereof.
Correct. So basically, all their front end of comminution is dry, and then they get into a wet process once they go into your 80 micron. So your fine grinding would work with vertical stir mills and magnetic separators, and then that becomes your wet process. But the entire comminution is done dry with a combination of multiple HPGRs in series.
So there's some very interesting things happening here. And any final words? Anything you'd like to leave with our audience?
Yeah, I think in conclusion, Weir is a global company. Nobody serves more mine than Weir. And Weir is dedicated to sustainability. And anytime we work with our customers, we look for the most efficient and best solution. And very proud to have worked for Weir for all these years, and will continue to make the mining industry a better place.
Very interesting. I've been speaking with Phil Blondin, and he is with Weir, and we've been talking about sustainability and all the great things that Weir does. And Phil, thanks for joining us on Mining Now. It's been a very interesting conversation. And thank you to our audience for joining us. Mining Now from the trade show floor at PDAC. Thank you for watching Mining Now.